To section 4. Today we're going to put some things together that we've been talking about. We've been looking at solving inequalities. So today we're going to just look at solving multi-step inequalities, keeping in mind that we are going to be using inverse operations to isolate our variables. So when we move things across that inequality sign, we're going to work backwards through PEMDAS to get our variable by itself. And also, one other thing to keep in mind is that when we're multiplying or dividing by a negative number, we need to reverse the direction of that inequality. All right, so let's start off with example 1a. We got some number being divided by -2 plus 4 more is greater than -1. So we're going to undo that addition and subtraction first by subtracting over that 4. We have our variable divided by -2 now is greater than -5. And now we're going to undo that division by multiplication. We're going to multiply both sides by -2. And remember, when you multiply by a negative, you must reverse the direction of inequality. So now we have all m's that are less than 10. All right, let's graph our solution set here on our number line. We have 10, 11, 12, and 9, 8. We got an open circle here at 10. And since we want all values less than 10, our line will point off to the left, and our shaded arrow will go off in that direction. Example 1b, we have 4 times some variable c plus 2 more is less than or equal to -1. So we're going to undo our addition and subtraction by subtracting 2 over to the right. I have 4c now is less than or equal to -3. I have 4, I need to undo that 4 that's being multiplied to the c by dividing now. And now I'll be left with just c is less than or equal to -3/4. Now remember, we're dividing a positive number, so we don't change the direction of that inequality. All right, so we'll graph our inequality set here. Here's -3/4. Let's just go to 0. Let's go to +3/4, and then here we have -1.5, so on and so forth. We want all values less than or equal to -3/4, so we're going to close our circle here at -3/4, and our shading will go to the left again. All right, example 2. Now you can see that we have some variables on both sides of the inequality sign. So that's okay. This is going to work the same way that we've solved equations with variables on both sides of the of the equal sign. We're just going to combine like terms. So we're going to subtract our 3n over to the left, and simultaneously we're going to add 6 to the right. All right, that gives us 5n minus 3n, and that's going to give us 2n is greater than or equal to 4 plus 6, which is 10. Dividing both sides by 2 now to get n by itself, I'm left with n is greater than or equal to 5. And again, keep in mind, we're dividing by a positive number, so we don't change the direction of the inequality. All right, we'll graph our solution set here. We'll throw 5 down here in the middle, 6, 7, 8. 4, 3, 2, and we're going to have a closed circle here at +5, and everything shaded to the right, indicating you want values that are greater than 5. All right, example 3 presents us with a couple of more solutions, or different types of solutions, I should say, with these inequalities. So we're going to solve these just like we would with an equation. Simplify the right side first by distributing 2 to the 3t and the +5. All right, so here's my equivalent inequality. 6t minus 4 is greater than 6t plus 10. All right, let's combine like terms. We're going to subtract our 6t to the left, and when we do that, we have 6t minus 6t, which are additive inverses, so they add to 0, and I'm left with -4 is greater than +10. Notice that my variables have been completely eliminated, and I come up with this statement of -4 is greater than 10. Now, is this a true statement or not? That's the question. No, -4 is never greater than 10, and because you come up with a false statement here, there are no solutions to this inequality. So here we're just going to say no solution, and if we tried to graph no solution on our number line, it would just be a blank empty number line. All right, example 3b has another similar situation. Let's simplify the left side here by distributing in our 2, and that leaves us with 4x minus 6.6 is less than or equal to 9 plus 4x. Notice that we have a positive 4x on both sides of this inequality. So here's what happens when we move over 4x to the right side. We have 4x minus 4x. Those will add to 0, and I'm left with negative 6.6 is less than or equal to, and on the right side, my 4x's will add to 0 as well. And I'm just going to be left with positive 9. So I get this statement, negative 6.6 is less than or equal to 9. Well, again, ask yourself, is this a true or false statement? Yeah, it's true. Negative numbers are always going to be less than our positive numbers. And because it's a true statement, we know that there are infinite number of solutions. And when there are infinite number of solutions, when we graph that on our number line, what we're going to do is we're going to graph the entire number line. So watch this. We're going to create a nice, big, thick line here. And we're going to graph that all the way across. Let me turn that guy off. Graph it all the way across, and another big arrow over here on the right. So there's the graph of infinite solutions, all real numbers. All right, I'm going to change my pen back here. And let's finish up with our final example here. You've bowled 4 games with the following scores of 128, 113, 159, and 144. What do you need to bowl on your 5th game in order to average at least 140? So remember, to find average, we add up all of the numbers, and we divide it by the total number of numbers we added up. So let's add 128 plus 113 plus 159 plus 144 plus there's a 5th game that we're going to bowl, but we don't know what the score is yet. We want to figure out what that score needs to be in order for this average here, add up those 5 games, divide by 5, in order for this average to be at least 140. That means it has to be greater than or equal to 140. All right, to solve, we are going to combine like terms on the left-hand side here. When we add 128, 113, 159, 144, we're going to come up with 544 plus x. Divide that by 5, and that should be greater than or equal to 140. Next, we're going to multiply the 5 over to the other side here in order to get it out of the denominator. And I'm left with the equation 544 plus x now has to be greater than or equal to 5 times that 140, which is 700. And now I need to subtract my 544 from both sides. And that's going to give me an x value, or in other words, that value of that 5th game has to be greater than or equal to 156. All right, if you think you can bowl more than a 156, come talk to me, because I'm the bowling coach, and we'll sign you up for Zealand Bowling.